The first question, which state of matter is associated with the very highest of temperature? We all know there are three states of matters: solid, liquid, and gas. When we apply high temperature to a solid, it changes to a liquid, and when we apply a high temperature and heat to a liquid, it changes to a gas. The particles in gas are further away from one another and take the shape and the volume of their container. But if we continue to apply heat to the gas, the substance will change from a gas to a new state of matter called plasma. This needs a very high and strong heat. In the state of plasma, electrons are stripped from their respective atoms, creating free electrons and positive ion. So, plasma is neutral, as there are positive and negative particles in equal amount. So, let me summarize this. We need to apply a very high and strong heat to substance to reach the plasma state to create free electrons and electricity, as free electrons means electricity. So the answer is plasma, and the very high temperature is associated with plasma, not a gas. Sorry. The second question. A copper wire of length 2 meter. Here we have the length, or let me see, L note, and the cross section area 7.5 times 10 power negative 6 meter square. This is the cross section area, and we have Young's modulus 11 times 10 power 10 newton per meter square, and we have a mass um, 200 hanging from the wire. From the mass we can calculate the weight and the weight is simply the force. So we can calculate the force using the mass. What is the increase in it? So he simply wanted to know delta L. To calculate delta L, or the increase in length, we have to know the strain. And as he didn't give us strain in the givens, we can use Young's modulus to calculate the strain. Young's modulus is simply equal to stress over strain. So strain is equal to stress over Young's modulus. So we have to calculate the stress, as he didn't give us the stress as the givens. Stress is equal to force over cross section area. He didn't give us the force. So first we have to calculate the force or the weight. Force is equal to weight is simply equal mg. So 200 kilograms times 9.8 is equal to 1800 900 sorry and 60 newton. So this is a force. After this we have to calculate the stress to use it in Young's modulus to calculate the strain. Stress is equal to force over cross area. The force we just calculated is 1960 over the cross section area. Gave us the cross section area in the given 7.5 times 10 power negative 6 10 power negative 6 is equal to this big number. You can use the calculator to calculate it. So here we have the force. Here we have the strain, and we have Young's modulus as a given, so we can use the stress and the Young's modulus to calculate the strain. So Young's modulus, Young is equal to stress. So strain is equal to stress over Young's modulus. Stress over Young over youngest modulus is equal to stress. We just calculated. This is a big number. I can't read it, to be honest. 6056 over the youngest modulus he gave us in the question times 11 times 10 power negative 10 power 10 10 power 10. This is equal to 2.5 times 10 power negative 3, 10 power negative 3. And there is no unit for strain, as is the ratio between the stress and youngest modulus. Stress is have the same unit as youngest modulus, so there is no unit for the strain. As we have the strain and we have L naught, or the actual length, he gave us the question, the actual length, in the first of the question, in the beginning of the question, he gave us the L naught is equal to meter, so strain is equal to delta L, or the change in length, but yeah, let me summarize this. Delta L, the change in length over the actual length. So if we want to calculate the change in length, it is simply equal to the strain times the actual length. So the change or the increase in length, it's simply the change in length. The change in length is equal to strain times the actual length. Strain times actual length is equal to the strain we just calculated is 2.5 times 10 power negative 3, 2.5 times 10 power negative 3, and the actual length he gave us in the question is equal to times 2, so the result will be 5 times 10 power negative 5 times 10 power negative 3 meter. This is the result, but in the choices he doesn't give us the answer in meter. All the choices is in millimeter, so we have to convert it from meter to millimeter. How we can do this, or how can we convert it from meter to millimeter? We just have to multiply our result in meter by 1000 or 10 power 3. So the change in length is equal to 5 times 10 power negative 3 sorry, 10 power negative 3 times 10 power 3 millimeter. So the result will be 5 millimeter. So the answer is D. Question number 3. An elastic solid is direct proportionality between strain and this is a very simple question. We all know stress, or youngest modulus, youngest modulus is equal to stress over strain is equal to stress over strain. So youngest modulus is a constant for every material. When you increase the stress, the strain will increase to reach the specific constant, or the constant of youngest modulus. So there is direct proportionality between stress and strain, as youngest modulus is constant for every material. I hope you understand this. This question. The quantity stress expressed in terms of fundamental quantities mass, length, and time is equivalent to. Here he simply wants to know the dimensional formula for the stress. To know the dimensional formula for the stress, we have to write the rule for the stress. Stress, as we know, is equal to force over area. Very simple rule. Force, sorry, over area. Okay. If we want to know the dimensional formula for the stress, first we have to know the dimensional formula for the force and the dimensional formula for the area. Dimensional formula for the area is very clear. Dimensional formula for the area is equal to L power 2 or L square. How? When you want to find the area of any shape, for example, the area of a square is equal to the length by times the length is equal to L square. This is the square. Okay. If we want to know the dimension to calculate the area of a rectangle is equal to the width times the length. Width is also the length. We can express the width by L and we can express the length by the L. So it's simply equal L square. The area of triangle is also half base times height. Base is a length and height is a length. So in all cases you will find yourself multiply a length by a length. So the area, dimensional formula for the area is L square. It's very clear. The point is to calculate or to know the dimensional formula for the force. Force is equal to MA. M is mass. The dimensional formula for mass is mass. The dimensional formula for the acceleration to know the dimensional formula for the force A is equal to V velocity over time V over T. The dimensional formula for the time is T. It's very clear. So we have to know dimensional formula for the velocity. Dimensional formula for the velocity is equal to velocity is simply equal to the distance over time d over t. D is the length. D is the length. It's very simple. So L over T. We can express it in another way to say LT power, or let me capital T power -1. Sorry, power -1. This is the dimensional formula for the velocity. We have to know the dimensional formula for the acceleration. Just 1 minute, 1 second. I'm sorry. We know the dimensional formula for the velocity. We just know it. L t power -1 over t. Over t. We can say it in another way. L t power -2. This is the dimensional formula for the acceleration. So the dimensional formula for the force is simply equal to m times the dimensional formula for the acceleration L t power -2. So now we can note the dimensional formula for the stress is equal to the dimensional formula for the force, which is m L t power -2 over L power -2, which is the dimensional formula of the area, power -2, is equal to simply m L power -1 power and t power -2, t power -2. So the answer is B. Very easy question. Okay. The quantity strain expressed in terms of fundamental quantities, mass, length, and time is equivalent to. Here he wanted to know the dimensional formula for the strain. As I just said in one of the questions, strain have no unit because it's the ratio between a length and the length. It's the ratio between delta L and L naught, and delta L is the length and L naught is the length. So it is a dimensionless quantity. So the answer is D. And it is a it's a very Important to know that any quantity is a ratio between two things have the same unit is a dimensionless quantity. So let me write this to make it more clear. Strain is equal to the change in length over the actual length. So it's simply L. The change in length we can express it by L, and the L naught we can express it by L. So L over L is nothing. It's 1, and 1 a dimensionless quantity. So the answer is D. The bulkiest modulus of a material is a meaningful physical property is applicable to which of the following? Only solids, only liquids, only gases. Solid, liquids, and gas. Very, very clear. The answer is D. We can apply Young's modulus for a solid, liquids, and gas. If you want to know more about it, you can read the chapter. Question number 7.